Hi friends, welcome to my another video. Today in this video, I will take one 2 BHK architectural layout and I will make a power layout for this 2 BHK. Apart from that, I will make the light layout for this 2 BHK. After that, after preparing the power layout and lighting layout for this 2 BHK, I will prepare one load schedule for this 2 BHK. But these all designing will be as per DEWA regulation. Before starting this, let us understand what are the rooms this 2 BHK consists of. So here you can see that there is one master bedroom. Okay. Then we have the master bedroom toilet. Apart from that, we have one dressing room which have some cabinets. Then we have one kitchen children bedroom and we have children bedroom toilet. Then we have one laundry and one storage area. Then we have one powder toilet which is for the guest use. Then we have one maid room and maid room toilet. We have one open kitchen and we have one dining and living area. Let us place first double socket and single socket as per requirement. So here there is one master bedroom, so we need one double socket here, and here we need double or single socket. So let us take single socket. Here in front of the bed we will place the TV, so we will require double socket. Now let us move to our next room, that is the children room. Here also the same. Near the bed we need one double socket, other side we need single socket, and in front of the bed we need one double socket for the TV power. Now let us move to the living and dining area. Here you see there is one TV placement, so we need one double socket near the TV. Here you see there is a sitting arrangement and this is the wall, so we will place one socket here and one socket will be here. It could be single socket or double pin socket. Now we will place the single or double socket for the dining area. So we will place one double socket here near the dining table, and for the maid room we will place one double socket here, and we could place one more socket here for if in the maid room. Apart from that, we need one socket also here for the corridor and for the cleaning purpose. Completing the single and double socket placement, we will consider the power points for the FCUs. Here you can see there is one FCU. Here there is one FCU. Here there is one FCU. Here there is one FCU. This FCU will feed the maid room and its toilet. This FCU will feed the living and dining area and the passage. This FCU will feed the children bedroom, and this FCU will feed the master bedroom and its related passage and dressing room. So we need to arrange the power for this FCU. For that we will place one spur outlet for the FCU. So here I place one FCU spur outlet. Here I place one FCU spur outlet. Here I place one FCU spur outlet, and here I place one FCU spur outlet. Hope you are clear. Let us focus to place our power outlet as per the required load in the kitchen. Here you see this is the fridge. This is microwave. Here there is a oven and hob inbuilt. We have one dishwasher here. So we will place our power outlet as per the equipment. So for the fridge we need one 13 ampere socket. For the microwave we need one 20 ampere socket. Okay. For the oven we need one 32 ampere socket. Okay. For the hob we need 145 ampere socket. 45 ampere. And for the dishwasher we need 120 ampere socket or spur out or flex outlet. Okay. As per the DEWA regulation, we have to provide the DP switch also for some equipments like for hob, oven, microwave and dishwasher. If you're wondering how I selected the rating for the microwave, oven, hob and dishwasher, This you will check it from the catalog of the final fixtures like microwave, oven, hob, dishwasher. Then you will find their load also. Based on their load, you have to select its flex outlet rating and in dB their breaker rating. So as per the DEWA regulation, for some appliances we need DP switch. So for the dishwasher I put one DP switch which is of 20 ampere also. For the hob we will put one DP switch which will be of 45 ampere. For the oven we will place one more DP switch, double pole switch, which would be of 32 ampere. For the microwave we will put one DP switch which would be of 20 ampere. Apart from that, we need some general purpose socket for our general purpose application like to energize the grinding machine, coffee machine, etc. So we will put one double socket here and one double socket here for the general purpose application inside the kitchen. Hope you are clear till here. After the placing power socket based on the equipment in kitchen, now let us focus in the laundry area. This is laundry area. In the laundry area, we have two things. One is washing machine, one is water heater. Here in this apartment, it is centralized water heater, meaning in each bathroom we don't have any water heater. We have one water heater for the full flat and it will supply the hot water to every bathroom. Okay. So here there is a one circulation pump also to circulate this hot water within this flat. So we have three appliances here. One is washing machine. Hope you can see here WM. One we have water heater and one we have circulation pump. Here it is mentioned. It's not shown here. It is circulation pump. So we have three appliances here. For the washing machine we need one flex outlet of 20 ampere and we need one DP switch for that flex outlet which would be of 20 ampere. Apart from that, we will placing one isolator of 20 ampere for the water heater and one isolator for the circulation pump of 20 ampere. Now after placing all the power outlets as per our requirement, we have to consider the load for each power outlets. As per the DEWA regulation, the single socket, on the single socket the power assumed is 200 watt. So this power socket will have a load of 200 watt. In same way, this is the double socket. So the power assumed or load assumed on this double socket will be 200 plus 200, that is 400 watt. In same way, we will write for all the power outlets. So here I will write it is 400 watt. It will be also 400 watt. It will be also 200 watt. This will be 400 watt, 400 watt. This will be 200 watt. Wherever you will find the general purpose socket, write the assumed load as per the DEWA regulation. Like for the single socket it will be 200 watt. For the double socket it will be 400 watt. After writing the single socket and double socket load, we have to write the load for each FCU. Here all the FCUs are typical and the load of each FCU is 350 watt. So I mention here 350 watt. I mention here also 350 watt and here also I mention 350 watt. After that we have to write the load of the equipment placed in the laundry. So washing machine have a load of 100 and 1200 watt. Circulation pump is 220 watt. Water heater, which is a general water heater for the all flat, having the load of 1500 watt. If we will write the load of the kitchen equipment, then the fridge is of 250 watt, microwave 350 watt, oven is 500 watt, hob is 6000 watt and the dishwasher is 1200 watt. So we write all the loads of the equipment which is placed in this 2 BHK flat. If you are wondering how I wrote the load for each and every equipment, then I will tell you, from the client these all equipment will be approved and we will refer the material submittal for each equipment to get the load of that equipment. So by referring the FCU material technical submittal, we will get the load of the FCU. By referring the water heater technical material submittal, we will get the rating of the water heater. In same way for the washing machine, microwave, freezer, oven, hob, this you will receive from the client or from the consultant also. So based on referring that document received from the client or from the consultant, or by referring the technical submittal, you will get the load of each equipment. There is one more thing I want to add here. If you don't have any information regarding the equipment load, then DEWA also having some general loads for each equipment. And based on these equipment, based on the load of that equipment, we have to make a load schedule. But DEWA is also emphasizing that write the actual load, because in any way you have to reflect the actual load in the as-built submission for the DEWA approval. So better refer the load a technical submittal for the actual load for the equipment. Placing the electrical outlet as per the equipment requirement, we will make the circuit formation between these electrical outlets, but it will be as per DEWA regulation. So before starting the circuit formation between the electrical outlets, let us understand what DEWA says. So the first thing which you will observe in the DEWA regulation is that any appliances is rated more than 20 ampere, then we have to use DP switch for that equipment. So any equipment which having the load current more than or equal to 20 ampere, we need to put DP switch for that equipment. In our case, you notice that for the microwave, for the oven, and for the hob, we provided DP switches depending on their rating. Like for oven, I provided 32 ampere, for hob I provided 45 ampere, and for microwave I provided 20 ampere DC switch. So this is the first thing we observe from the DEWA regulation. Apart from that, you will find that the cooker unit should be 2 pole for single phase and 4 pole for 3 phase application, and the cooker unit must be feed through ELCB which having the sensitivity rating of 100 milliampere. The other thing which you will find that the cooker wire size will depend on the rating of the cooker. Here the cooker and hob is the same. Okay. Now the other thing which you will find on the DEWA regulation is that every heater circuit shall be protected through 30 milliampere ELCB or RCCB. For the AC unit, there is one important point mentioned here, that the maximum of 2 air conditioning unit can be connected in a single circuit. Okay. And the other thing which is mentioned, that depending on the rating of the air conditioning unit, we have to select the breaker rating as well as the wire size, but minimum size to be 20 ampere for the breaker and 4 square mm for the wires. Apart from that, we will see in the DEWA regulation that in a light circuit, the maximum load allowed is 200 watt and the wire size should be 2.5 square mm and the breaker rating must be 16 ampere. Other thing which you will find on the DEWA regulation is that the maximum 513 ampere sockets are allowed in a radial circuit, and 10 socket outlet can be looped together in a ring circuit. Here also mentioned that the radial circuit must be fed through a 20 ampere breaker, and the ring circuit which having maximum from 5 to 10 single socket must be controlled by 30 ampere circuit breaker. Here we will take 32 ampere circuit breaker for practical reason, means because 30 ampere circuit breakers are not available in the market. So for the ring circuit we will use 32 ampere breaker, and for the radial circuit we will use 20 ampere breaker. Apart from that, in the DEWA regulation, it is mentioned that the assumed load on a 13 ampere single socket is 200 watt. Okay, and on a 15 ampere socket, the assumed load is 1000 watt for the residential building, and for the commercial and industrial building, it is 500 watt. Hope you understood this point. The other very important point mentioned in the DEWA regulation is that in a residential premises where the power supply is 3-phase, then as far as possible, the light fittings, socket outlet, water heater and cooker and other single phase appliances installed within a room shall not be connected to more than one phase. What does it mean? Suppose here we have one master bedroom, okay, then we have some sockets, then we have some lights, in the bathroom we have FCU, then these all loads, whether it is the sockets, light, FCU is per outlet, any heater, it should be fed from either R phase or by Y phase or by B phase. Meaning, we should not mix two phases in a single room. But as far as possible, we have to maintain that thing, that we should not mix two phases in a single room. But wherever it is not possible, then we have to maintain minimum 2 meter distance between the two different phases. Hope you understood this one. After discussing some of the DEWA regulation points related to design the circuit formation within a flat, we will start the circuit formation. So here I will start from master bedroom. Here we have 3 double sockets. Okay, so we will make one circuit formation between these outlet. So I will make one circuit and it will go to DB. Here you have to notice that we have total 6 single outlet, or we can say 3 double outlet. As per DEWA regulation, how many sockets are allowed in a radial circuit? That is 5 socket. Okay, but here we have 6 sockets, 2 plus 2 plus 2. So we have to go for the ring circuit. So the main will be supplied from both the end. Hope you understood this one. Now let us move to the other bedroom, that is the bedroom number 1 or children bedroom. Here you will see there is one double socket, one single socket and one double socket. And in the corridor also we have one single socket. So we will loop these all sockets together to make the circuit formation. So I will loop it here. Here you also see that there is total 2 plus 1 3 plus 2 5 plus 1 6. Total 6 single socket. Then it would be a ring circuit, because after 5 single socket we need to make a ring circuit. So here also we make one ring circuit. That is, the supply will come from both end of the circuit. Now we completed the circuit formation in the master bedroom and the circuit formation in the single bedroom. Now let us make the circuit formation in living and dining area. So here you find that there is one single socket, one single socket, one single socket and one double socket. So let us start the circuit formation. Here you observe that there is total 5 single socket in that loop. 2 plus 1 3 plus 1 4 plus 1 5. So it need only a radial circuit. So we will make one main supply from the DB. And as it is only a 5 circuit. Now let us make the circuit formation for the maid room. Here I will take the maid room sockets loop with the fridge, which is placed in the kitchen. So I will make one circuit. So I make one circuit between the maid room outlet and the fridge. Here you see that there is total 4 outlet in a circuit. 1, 2 and 1. So total 4. So it will be a radial circuit. After making the circuit formation for a general purpose socket, now let us focus on a FCU circuit formation. As we discussed in the DEWA regulation, that as far as possible we should not mix two circuits, two phases in a single room. So already we have taken a blue phase for the single phase. We have taken blue phase for the general purpose socket in a master bedroom and in a bedroom number 1. So the blue phase must be considered for making the circuit formation for the FCU. In that way we will not change the circuit color. So let us make the formation of the circuit for FCU. Here I want to highlight one more important point, that during DEWA regulation explanation, I told you DEWA allow maximum 2 number of FCU in a single circuit. That's why I make 2 FCU in a single circuit. Hope you understood this one. Now let us make the circuit formation for this FCU and this FCU. As you see that we have taken the red phase for the maid room and maid room toilet. So we have to use the red phase only to make the circuit for the FCU. So let us take the red phase. And the main will go to the DB. So what we have done, we have made the circuit formation for the FCUs, and we consider DEWA regulation during formatting the circuit for the FCUs. What are the things we consider? We consider that single room should have a single phase, and we should not mix the other phase in a single room, which we have done. We have taken the made room for the general purpose socket as a red circuit, so we make the FCU circuit formation from the red circuit only. In the master bedroom, we have taken the blue phase for the general purpose socket circuiting. Then we have taken the blue phase only for the FCU circuit formation. The second thing what we have followed from the DEWA regulation, that DEWA said there are two FCUs are allowed to connect in a single circuit. So we have connected two FCUs in a single circuit, here also and here also. But here I want to highlight one more important point. If the load is more on the circuit, then we can take a single FCU as a single circuit. But here the load is very less, 350 watts, then we have an option, and DEWA also permitting to make two FCU in a loop, so we looped it. Hope you understood so far. Now let us make the circuit formation for the kitchen equipment. Here you see that there is one microwave and its DP switch. So let loop the DP switch with the microwave flex outlet, and the circuit will be radial. So one main will directly come from DB. Here you see there is a oven and its DP switch. So let us loop this oven flex outlet with its DP switch, and it will be also a radial. So one power supply circuit will come directly from the DB. In same way, we will loop the flex outlet of the hob with the DP switch, and one main will come directly from the DP to the hob DP switch. Might be you are wondering how I am considering the blue phase, yellow phase, red phase in a different room. This is try and trial method, meaning we have to make the circuit formation and we have to check the balancing in the load, like R phase and Y phase and B phase are equal or not. Depend on that trial method, we have to change the circuit number during designing. But in order to avoid the longer video time, we have tried in previously before making this video, and then I am making the circuit color. I will give you one trick to balance the load in 3 different phases easily. You have to identify that which one is the bigger load compared to the other load. Like in this flat, the hob is the biggest load in this flat, which having a load of 6000 watt. Suppose I consider the yellow circuit for the hob, then don't use yellow circuit for the other phases. Okay, in this way you will balance the load between the 3 phases easily. Here if you notice, I consider the yellow phase for the hob, then for very few circuit, only one circuit I use the yellow phase, and other all loads I connected either with the red phase or with the blue phase. If you will do so, the balancing will be easy. I will tell you one more important thing, that if you will practice more for the designing, then you will automatically have the critical thinking that how to, during designing stage, you will come to know that if we will add in the red circuit or Y circuit or blue circuit, the load will become imbalanced or it will become more balanced. This will come with the practice. Let us focus for the equipment placed in the washing area, laundry area. Here we have one washing machine, we have water heater, and we have the circulation pump to circulate this hot water throughout the all toilets. So the washing machine having a rating more than 20 ampere, then as per DEWA regulation, we need one DP switch and it will be a radial circuit. So let us take a circuit. I'm considering for the washing machine, it is a red circuit. Okay, for the circulation pump, I'm taking as a blue circuit and it will directly go to DB. For the water heater, I'm also taking blue circuit, which is directly fed from DB as a radial circuit. Hope you got the power outlet distribution and its circuit formation from this overall discussion. We will make now the light circuit formation for the same flat, and then we will proceed for the preparation of load schedule. Let's start designing the light layout for this 2 BHK flat. DEWA don't have any hard rule for the light layout. What DEWA has a rule related to light, I will explain you now. DEWA said for the light related regulation, in a particular load, in a particular circuit, suppose there is 5 lights. Okay, combining load of these light should not exceed 2000 watt. Meaning, suppose there is a 5 light and the total load combined of this 5 light is 2000, meaning each light will have a load of 400 watt in this case of example. So 400, 400, 400, 400 and 400. So 400 into 5 is equal to 2000 watt. So what DEWA said, for a particular circuit, how many light is there, DEWA is not considering that one. But the combined load for that light should not exceed 2000 watt. Hope I'm clear. The second rule related to light is that the light circuit must be controlled by an ELCB, which should have the rating of 100 milliampere or in some case 30 milliampere. Like if some lights are feeding in the garden area or in the wet area, so the light could be controlled by the ELCB, which should have the rating of 100 milliampere in normal situation, and in some special situation it should be controlled by 30 milliampere. Apart from that, DEWA has one more important regulation related to light, is that the light circuit wire must be 2.5 square mm, phase wire, neutral wire as well as earth wire. This should be the wire size of the light circuit. One of the important point mentioned in the DEWA regulation related to light is that suppose at the design stage the light is not decided. When you are designing the drawing, the light is not selected by the client or by the consultant. So then how we will calculate the load on a particular circuit? DEWA said if the light is not selected, then for a particular one light you have to consider the load of 100 watt each light. You have to assume that the load on each light will be 100 watt and the circuit breaker for that circuit will be 16 ampere. Hope I'm clear. After discussing the DEWA regulation related to light, let us make the circuit formation for the light. Here, before making the circuit formation for the light, I'll tell you the load which I took for different types of light. The dry area lights, this brown color dots are representing the dry area lights. Okay, that light load is 8 watt. The wet area lights are indicated from the green dots, in the laundry area, in the toilet area, in the powder bathroom, in the male toilet. This light load is considered as 22 watt, and these all green lights are typical lights. All brown lights are typical light. And the load for the chandelier light is taken as 300 watt. And the load for this strip light is 14 watt per meter. Okay. The main room light have a load of 18 watt and the balcony light have a load of 20 watt. This I took the load from the light technical data sheet because in my case the light is already approved by client and consultant. So I know the light is approved. So I refer the technical submittal and I find the light load for each light. Now after getting all this information, now we can make the circuit formation for the light. You know that in the power layout, I took the general socket circuit as a blue circuit for the master bedroom and for the bedroom number 1. For the dining and living area, I took yellow circuit for the general purpose socket. And for the maid room and maid toilet, I use red circuit for the general purpose socket. And for the kitchen, I use red circuit, and only for the hood I use yellow circuit. Sorry, for the hob I use yellow circuit. And for the laundry, I use red circuit and blue circuit. Red circuit is for washing machine and blue circuit I use for circulation pump. This we know. And during power circuit formation, I told you that as per the DEWA regulation, 2 phases we should not mix in a single room. So before we use blue circuit for the power sockets, then for the light sockets also we have to use the same phase, that is the blue phase. In same way, in the living area, we used yellow phase for the power circuit. So this time for the light layout, we have to use same yellow circuit for the yellow phase for the light circuit formation. So now we can start the circuit formation for the light. So we will make the circuit formation first for master bedroom and master bedroom toilet area, which I am highlighting here. Okay, for this area we will make one circuit which will be obviously a yellow phase circuit, blue phase circuit. So let's start this one. From here I will take the power from DB and then I will loop it to this strip light. From this strip light I will give power to the other strip light. From this strip light I will give power to the wet area light, and I will loop it all the bathroom lights And from this bathroom light I will give one loop to strip light, and from this strip light I will give loop to chandelier light, and from chandelier light I will give one loop to the dry area light. So in this way we made one blue circuit for a light which covering the master bedroom, master toilet, and the master bedroom related dressing room and its corridor. After formation of the light circuit, let us give the control of that light circuit to its related switch. So this light and this light will be controlled by this switch. This is two gang one-way switch. Okay, meaning one gang will control this light and another gang will control this two strip light altogether. So we will give the control of that light to that switch. In same way, this toilet have 4 light and 1 strip light. So let us give also control of this light to this switch. One gang will control this all 4 light and another gang will control this strip light. This is a symbol of two-way light, means you can turn on and off the light from here as well as from here. So we will give control of this light and this light to two gang two-way switch. So we give control here and we give control here. So now we can on and off this two light from here itself as well as from here also. In the case of two-way switch, we have to give one separate loop switch to switch in order to control this switch as a two-way switch. So we will give one loop switch to switch. More than that, if you will design the light circuit, you will find here letter mention like A, B. Here somewhere you will find C, D. Here you will find E, D. Here you will find, that's it. These are the switches. So what does it indicate? With this you will find the same letter mentioned here, A, B and B. Means that gang B will control this two light and gang A will control this light. So here there is a C and D. So this will be all C and this will be D. Means one gang which name is D will control the strip light and the gang which is indicated by letter C will control this 4 light. In same way, here it is mentioned E and D. So suppose this one is E and this one is D, meaning the D indicated gang will control this light and E indicated switch gang will control this light. Same way here, it will be indicated as E and D. Why we mentioned 2 times? Because it is a two gang two-way switch. Means same operation we can do from here. In same way, we will make the light circuit formation for this bedroom one also. As we know that we use blue phase for the power circuit in this bedroom. So we have to use blue circuit only for the light circuit formation also. So let's start this one. From here, we will take the power supply from DB. Okay, then I will loop to this light. From this light, I will give loop to this light, and from this light to this light to this light, and finally from this light to this light. Now let us make quickly the switch wiring. This light, strip light, is controlled by this switch. So we will give one wire to this light to control by this switch. This is a two gang switch which is controlling these two lights. So we will give the circuit from switch to the light to control this switch. Here we have one two-way two gang switch which will control these two light and this light. So we will give quickly circuit to this switch from this light and this switch, this light to this switch. If we will do the numbering, then we will say if this switch is A, then it will control this light, and if this one is B and C, then it will control this light and this light, and if it is E and F, then this control one E control this light and F will control these two lights. Hope you are clear. Now video will be too larger if I will do for each room. Now you have the concept how to make the light circuit formation, and you are now familiar with the DEWA regulation related to the light. So I will prepare this one and then I will directly start the video to make this video length smaller. As we know that when we are making the circuit formation for the living and dining area, then we used yellow phase. So now also we have to use yellow phase for the light circuit formation. So here I use one power supply from DB. I loop this chandelier light to this chandelier light, and from this chandelier light to the balcony light. And we given the switch wiring from this light to switch and from this light to switch. Here I mention this switch name as M and N. So the gang which is indicated by letter M will control this light, and the gang which having in letter N will control this light. Okay, in same way, this switch will control this light. For the single gang switch, it is not required to mention the letter, but we are learning in this stage. That's why I wrote it, but actually it is not required because there is a one switch and one light. So obviously that switch will be for this light only. But we are in the learning process, so I wrote it so you have a clear concept. In same way, maid room, maid toilet, kitchen, powder bathroom, we use red phase for the power circuiting. So same way we have to use for the lighting circuiting red phase. So I started the wiring from DB, and then we loop this two light, then to the strip light, then to this light, then to the bathroom light, bathroom strip light, then to the powder bathroom light, then to the maid bathroom light, then to the maid toilet. And for the circuit wiring, if I will say, this light to this switch, maid room light to this switch, and powder bathroom to this switch, kitchen area light to this switch. Here I mention S and T. This S gang will control these lights and T gang will control this light. The other light indication is not important because there is a one gang switch and one light only. The other section is laundry area, store area, and the passage. Here we use yellow circuit. We given the power supply to this light, then we loop this light to this light, from this light to this light, from this light to this light, to this light to this light. Here there is a two gang switch. I mention it B and C. One gang B will control the washing area light and C will control this passage area light. This light will control this light, and this light will control store room light. Hope now you are very clear how to make the formation for the power circuit as per DEWA regulation and the light circuit as per DEWA regulation. I explain also in this video what are the important regulation highlighted by DEWA related to light circuiting, power circuiting. Now we will go for the load circuit preparation. This will be the tedious part. If we make this circuiting nicely, then the load scheduling will be easy. Otherwise we have to do some trial method, like we have to change this yellow circuit to blue circuit, and then again we have to reflect in the load schedule. But to make this video, I already made a trial, and then I made this load schedule, made this circuiting. So our load will be balanced only. But we will learn it one by one. As when I started the power circuit formation, before that one I explained the important regulation mentioned related to power circuit formation through the DEWA regulation. In same way, when I started the light circuit formation, then before that one I given some important DEWA regulation related to light circuit formation. Now we are in the stage to do the preparation for the load schedule. So let us study what are the DEWA regulation related to the final distribution board. If we will know the important points mentioned in the DEWA regulation related to final distribution board, then we can easily make the load schedule. The first thing mentioned in DEWA regulation for the final distribution board is it should be factory built. The other thing which is mentioned for related to final distribution board is that rewirable fuse is not allowed in the final distribution board. Only breakers and isolators are required in the final distribution board. The other important point mentioned related to distribution board in DEWA regulation that the distribution board must be keep in always in a accessible location. And apart from that, DEWA said related to final distribution board that distribution board must feed same floor services except for those loads which are in the staircase or in the common corridor in the high-rise building. Other than that, DEWA mentioned in the residential building, distribution board shall be installed inside a respective consumer premises. Okay, means we have one flat, then we cannot install that flat DB outside. It should be inside of the flat but near to the entrance. Okay. Apart from that, DEWA regulation highlights that the height of the DB from the finishing floor level must not exceed more than 2000 mm, that is 2 meter. Here it is mentioned 2 meter. There are some more important point mentioned related to final distribution board in DEWA regulation we will discuss now. In DEWA regulation we have the load schedule format. This load schedule format is for MDB, SMDBs. There is other load schedule format which is for the single phase DB. And we have one here, you can see this is the load distribution schedule for single phase DB. There is the load schedule format for three phase DB also. So here we will discuss in detail what are the things present in the load schedule format for the three phase final distribution board. Here we have the project name. We have to write the project name. Then we have to write the DB name. Then we have to write the upstream panel name from which that DB is fed. It could be SMDB or it could be directly from the MDB. Then we have to write the location of the DB. Okay. And apart from that, we will have several details also. We will discuss one by one. Here you see there is rating for the incomer. Here we have to write the rating of the incomer. Just for an example, if the total load connected and we come to the conclusion that it is 40 ampere 4 pole isolator. Okay. There is one column for the rating of ELCB, which is very important. As per DEWA regulation, maximum 6 circuit can be fed from one ELCB. So it will be section 1 that should be controlled by one ELCB. In same way, other 6 will be controlled by another ELCB. But it is not only applicable for the 6 circuit. One ELCB can control 3 circuits also. That could be section 3. And other circuit can be fed from another ELCB. That will be section 4. Hope you got the concept. The conclusion is the motto of the discussion is that one ELCB can control maximum 6 circuit. Okay. Minimum it can control 3 circuit, but maximum we can feed 6 circuit from one ELCB. Other than that, as per DEWA regulation, for the light circuit, which I already discussed, but I'm repeating here, for the light circuit, its ELCB rating must be 100 milliampere for normal lights, and for the special condition it could be 30 milliampere. But here we will focus on this because we are taking an example of normal flat. Apart from that, we discuss that the light circuit MCB rating must be 16 ampere. The wire size should be 2.5 square mm. Same way for the power, the ELCB rating 30 milliampere and the MCB rating will be minimum 20 ampere, and depending on the load it can go to 25 ampere, 32 ampere, 40 ampere and so on. Apart from that, we discussed that if there is a radial circuit for the general purpose socket, then the MCB rating will be 20 ampere, and if the general purpose socket is in the ring circuit, then the ELCB rating will be 32 ampere. Apart from that, we discuss that the load assumed on one single socket is 200 watt. The other thing which I forget here to discuss in light, that the total load we can connect in one light circuit is 2000 watt. Here I want to highlight one very important thing which will help us to make one load schedule. The thing is, suppose in this section we have MCB rating of 20 ampere, 25 ampere, 20 ampere, 20 ampere, 20 ampere and 25 ampere. So the ELCB rating will be double of minimum MCB rating, and in some cases it will be double of maximum MCB rating. What does it mean? Suppose generally this one is followed more popularly, so we will use only this one, but for the information I gave you another one also, but I will explain you each of them. Here in one section, this is ELCB1, ELCB1. It is controlling 6 circuit which having the MCB rating 20 ampere, 25 ampere, 20 ampere, 20 ampere, 20 ampere and 25 ampere. So which in these SMDB, which one has the least one? So 20 ampere MCB is the least one compared to others. What are others? 25 ampere MCB. So the ELCB rating will be double of the minimum rating of the MCB which is controlled by that ELCB. So the ELCB rating will be how much? 2 double of 20 ampere, that is 40 ampere. And how we will select the sensitivity rating of the ELCB? Depending on the load. If the load is power circuit, then the sensitivity rating for the power circuit will be 30 milliampere. Hope you are clear. Now I will give you one other example. Suppose in the same case, the ELCB rating will be equal to double of the maximum rating of the circuit breaker. Maximum rating. Which one is the maximum here? There is two type, 20 and 25. So maximum is 25, then it will be 50 ampere. So in this case, the ELCB rating will be 50 ampere. But this you will find in very few cases. The first one is popular, and in DEWA regulation it is easily approved. So we will go only which one has the least reading. We will make double of that. That would be the ELCB rating. I will take one more example. Suppose this time I will take light circuit. So light circuit is 16 ampere, 16 ampere, 16 ampere, 16 ampere, 16 ampere, because the light circuit MCB rating would be 16 ampere. In ADDC regulation, it is 10 ampere and 16 ampere. But forget this one. We are considering here DEWA regulation, so we will focus DEWA regulation point of view only. So the ELCB rating will be how much? Double of the minimum circuit MCB rating. So here all are 16. So 16. So it will be 32 ampere. And what would be the ELCB sensitivity rating? As it is feeding the light circuit, so the ELCB rating will sensitivity rating will be 100 milliampere. Hope you are clear. We have discussed so far the isolator rating, that is the incomer rating, ELCB rating, and the circuit number, which you already know, MCB rating, and the wire size. I told you that for the light circuit it will be 2.5 square mm. For the power circuit it will be minimum 4 square mm, and it will increase depend on the load. That would be 6 square mm, 10 square mm, 16 square mm. Okay. The ECC rating, that is the earth continuity conductor rating size, depend on the phase wire. Here I will tell you, if the phase size is less than 16, then the ECC conductor size will be equal to the phase size, that is S. Meaning 2.5 square mm, 4 square mm, 6 square mm, 10 square mm, 16 square mm will have the ECC wire size 2.5 equal to the phase. Okay. And when the phase conductor size is in between 16 square mm to 35 square mm, then the ECC wire size will be 16 square mm. What does it mean? Meaning, suppose the phase conductor size is 25, then it is lying in this term, then the ECC conductor will be 16 square mm. If it is 35, which is equal also I mentioned, so it will be 16 square mm. Okay. And if the phase size is greater than 35, then the ECC size will be S by 2. Suppose I have a cable of 120 square mm. Okay. Then the ECC size will be S by 2, that is 120 by 2, that is 60 square mm. But 60 square mm cable is not available in the market, so we will go for 70 square mm cable, next higher size. Let us take another example. This time the phase size is 185 square mm, which is greater than 35. Then the ECC earth continuity conductor size will be S by 2, that is 185 by 2, that is equal to 92.5. We don't have 92 mm size cable, so we will go for the next higher size, that is the 95 square mm. Okay. If the phase size is 50 square mm, which is greater than, lying in this condition, greater than 35, then the ECC size will be 50 by 2, then it will be 25 square mm. And we have 25 square mm ECC cable, so we will use 25 square mm cable for the ECC. Now we cover the CCT wires and ECC wires. This will be the room name. Depend on the load, we will write the room name. Okay. And suppose in the master bedroom I have 2 chandelier lights, so I will mention here 2, and I will mention the watt. The 1 minute. I will mention here the watt of each light. So each light watt is 300 watt. So what would be the total load on the R circuit, R1 circuit to be specified? Then it will be 300 watt into 2 light, that is equal to 600 watt. In same way, suppose in Y it is master bedroom toilet. Okay, here we have 2 light and 1 strip light. So we have to write like this: 1 strip light, 2 light. Suppose the 2 light has the load of 18 watt and 1 strip light which is of 5 meter, then it has a total load of, let's say, 20 watt. So what we will write here, the total load on Y1 phase will be 2 into 18, that is 36, plus 20, watt. That would be 50 watt. Hope you are clear till here. I will give you a detailed description of this calculation when I will actually calculate, I will actually prepare the load schedule for the 2 BHK flat. But here I am giving you the concept. Okay. In same way, we will write the room name here. Okay. And what is the type of load? Suppose this is one water heater. So we will write this one. So we will come to know this room has like laundry area. I will write laundry area, and it has one water heater, and the load on the water heater is 1200 watt. For example, I'm saying then 1 into 1200 watt, that is equal to 1200 watt, and it will be on B circuit. So we will write here 1200 watt. Depending, suppose I will give you one more example. Like we have one living and dining area. Okay, living and dining area. We have 13 ampere socket, that is total number of 13 ampere single socket is 8. For example, okay, what I told you, assume load on each socket is 200 watt. So 200 into 8 is equal to 1600 watt. Okay, and it will be on the R3. So the unit load is 200 watt. Here it is written watt per unit, and the total load on the R3 will be 8 into 200, that is 1600 watt. Hope you are clear. In same way, we will fill the R phase. Here the value will come, and again the value will come here, again the value will come here, because this one will be filled by Y phase and this one will be filled by B phase. Same way, we will add the R phase here, we will add the Y phase here, and we will add the blue phase here. After summing up the load, it will call the load per phase, and that phase is R phase. In same way, load per phase, that would be on Y phase, and load per phase on B phase. And our intention that to make this load balance means, suppose here it's coming 7.2 kilowatt, then this load on Y phase should also come nearby 7.2 kilowatt. It could be 6.9 kilowatt, and in B phase it could be 7.1 kilowatt or 7.2 kilowatt. The motto is the load per phase should be very close to each other. Then we can say that dB is a balanced dB. And when we will sum up these three loads, load per phase, then we will get the total connected load on this dB. Hope you are clear so far. This is a very long video. In my next video, I will prepare the load for the example which I have taken, that is the 2 BHK flat, one by one, and we will step by step learn how we are taking the load and how we are balancing the load in a load schedule. So in part 2 video, I will prepare the load schedule based on the example I have taken, that is the 2 BHK flat. I hope you find my video informative. If you really like this video, then please hit thumbs up button and subscribe to my channel. Please share this video with all your electrical friends. And I have a humble request that if you really find my video is worthful, then please subscribe my channel. It will motivate me to make such videos. It is taking lots of effort to make these type of videos. I hope you will subscribe my channel. We will meet in next video, which will be the part 2 video. And till then, take care, keep learning, and bye-bye. Thank you so much.